these are the notes for 7.4 part 1. This is the handout that you got about general solutions for arcsine, arccosine, and arctangent. These are going to be the inverse operations we're going to use when we solve trig equations. But for right now, we're just going to practice what general solution means and the solution in a given interval. Notice that this is a theta for degrees, and this is x for radians. And the big difference here is you're still doing the inverse of sine, but with degrees it's 360, and with radians we be multiplying or adding 2 pi. For sine, this is the one where we're going to take the inverse, but then also with that answer we're going to subtract it from 180 to get 2 possible answers, which I'll explain more in just a minute. For cosine, arccosine, we take the inverse of cosine, but we take the positive and the negative. And then for arctan, we're going to take the inverse and then just a difference of 180 adding on, or pi, because that's going to be that one half revolution apart. So let's take a look at examples with the given directions. So part A, we're going to find the general solution. And part B, we're going to find a solution in given intervals. So for the first part, our first example we're going to take a look at is if I have theta equals arc sine 0.7, and it says the degrees is an element of 0 degrees to 720 degrees. Since these are closed brackets, that means it can include 0 or 720. This just means element of, and this is a reminder that you're in degrees, not radians. So when we do arcsine, we're going to take a look at the inverse of 0.7, because that's what arcsine stands for, which is 44.427. And then what we're going to also do to get the second one is we're going to do 180 minus the inverse of sine 0.7, and we get 135.57. So now if I'm going to follow the directions, A, the general solution, is going to be this 44.427 plus 360n, and that just means that we can keep adding 360 to get more answers. We also have to include the second one, which is 135.57 plus 360n. So the general solution just means we're going to use that each time. Now for B, we have to do the given interval, and the given interval is 0 degrees to 720 degrees. So my first angle is 44.427. The next angle is 135.57. And now I have to find some more. So there's not going to be anything that's less this way, so I know that there's no answers that way. But there's going to be more answers this way, and we just don't want to go over 720. So to do that, we're going to add 360, and this answer would go there. And if I want another one, I can, whatever this answer is, I can add 360 to get this one. Now to get other answers, I can add 360 to this one. And then to this one, I can add another 360. So that's how you're going to get multiple answers. So we'll do that in our calculator. When I add 360 to the 44, I get 404.427. And then if I add 360 again, I get 764, which was over. So I don't need that one. If I went back to the red and I did 135 plus 360, let's see, I would get 495.57, which is still not too big. But if I add 360 one more time, would go over. So I know that these are all my possible answers in the given interval of 0 to 720. So you're either going to end up going over or too low, and that's all the answers. For the next example, we're going to practice the same idea, but with cosine. So with cosine, our example is going to be arc cosine 0.2, and this was a theta, so we know that we're in degrees. And theta is an element of 0 degrees to 720. And so for the general solution, how I'll solve that is say plus or minus the inverse of cosine 0.2. So with that in my calculator, I get plus or minus 78.46. And then I'm just going to add on the 360n for general solution, because that just tells me I can just keep adding 360 until I get all of my answers. So now for the given interval of 0 to 720 degrees, I'm going to first start with my smallest angle, which is negative 78.46, and then the next one would be 78.46. But I know that I can't use this one because that's less than 100, so this is kind of where I start. But I want to fill in these missing angles, so I can add 360 to this one to get this. When I add 360 to negative 78.46, I get 281.54. So I'm going to add 360 again, and I get 641.54. If I try to add 360 again, I would go over. So now I'm going to go to this one and add 360. And when I add 360 to that, I get 438.46. And if I try to add 360 again, I go over. So that I know that these are my answers. I needed this one. It's not an official answer, but I needed it to get the other one. And then finally, we're going to look at a tangent example. So I have theta equals arctan negative 4, and the angle is an element of the interval 0 degrees to 720 degrees. So for general, I'm going to say tangent, the inverse of tangent negative 4, which gives me negative 75.96. And then I'm going to add 180n because they're only a half a revolution apart. So for specific, I'm looking between 0 degrees and 720, the specific interval. So my first answer is negative 75.96, and then I need to get some more answers. From here, that is not going to be included in the answer, but I need it to add 180. And when I add 180, I get 104.04, and then I'm going to add another 180, which is 284.04, add another 180, 464.04, add another 180, and I get 644.04, and if I keep adding, I would go over. So those are all of my answers. The same steps will take place when you do radians, and I'll just show one example with radians how it would be a little bit different. So these were all degrees. So your first one for sine, second one for cosine, third one for tangent. So the only thing that shifts with radians is if I have x equals arc sine negative 0.2, notice that in the given interval, I now have 0 to 4 pi. 4 pi just happens to be the number 12.566, so that just tells me the interval with different numbers, but I'm in radians. So for the general solution, I would have inverse sine negative 0.2 equals negative 0.201 plus the 2 pi n, whoops. So now that we're in radians, instead of 360, it'd be 2 pi n. But then I also need that other one, the 180 minus. So now since I'm in radians, it's pi minus inverse sine negative 0.2 equals 3.3429, and again plus the 2 pi n. So now when I want to do the specific in the interval 0 to 4 pi, which is about 12.566, I am going to start with my negative 0.201. My next answer would be 3.3429. Again, these are the only ones I care about, but I need this for some answers. So if I add 2 pi to this one, I get this answer here, which is 6.08. I'm going to add 2 pi again, and I get 12.365. And then I'll go back to this one and add 2 pi. And you can just use the pi button for these. And let's see, 608, we get 9.62. And then these are all the answers in the given interval. And the same thing would happen if you're doing arc cosine or arc tangent. We would be using 2 pi or pi instead of 360 and 180.